Hello everyone. In this video, I am going to talk about select columns in dataset control and show you how to include or exclude columns from dataset in Microsoft Azure Machine Learning Studio. So let's get started. Get a dataset on Canvas. For demonstration purpose, I am going to use a saved dataset. There are number of saved datasets that are included when you spin up Microsoft Azure Machine Learning Studio. So expand the Save Dataset tab and Samples tab. You will see all the datasets that are present in Azure ML. I will be using Automobile Price Data dataset. Drag this dataset on Canvas. To visualize dataset, right-click on Output port of dataset and select Visualize. Here you will see the entire data that this dataset contains. It has 26 columns and 205 rows. This dataset has some missing entries. Now we have to get select columns in dataset control on Canvas. For that, go to left pane and look for Data Transformation tab and expand it. Go to Manipulation tab. You will see all the controls. Find for select columns in dataset control. Drag this control on the canvas. Now connect the dataset to this control. This control has a red mark which says value required. For that, go to the Properties pane and select Launch Column Selector. There are two options to include or exclude columns from a dataset. First is by name and the another one is with rules. Let's look at the by name option. By name method has two lists. One is available columns and the other is selected columns. Available column has three types. The first one is all types, which lists all the columns in the dataset. The other one is numeric type. This will list all the columns with numeric type, and the string will list all the columns with string type. To transfer the column in selected columns list, you have to click on the column, and with the help of arrow keys, you can transfer that column in the selected columns. You can also select multiple columns at one time by using Control key and transfer that with the help of arrow key. Now press OK. Now we will run the experiment. Now as you can see, the output is ready and we can visualize the dataset. Right click on the output port and select Visualize. As you can see, there are only 5 columns that are selected. Now let's try the other option. Select Launch Column Selector and select With Rules method. As you can see, the first parameter is Begin With, which has two options, all columns and no columns. Let's select all columns first. Below that, we have two options, Include and Exclude. Let's select Exclude option. The next drop-down list has 4 options to select columns: column names, column indices, column type, all features. Let's try each option one by one. Let's try column names first. Now click on the text box next to it. A list of column names will appear. Select a column name which you want to exclude. You can select multiple column names. I will select Normalized Losses column and press OK. Now run the experiment and let's visualize the output. As you can see, there is no normalized losses column present in the dataset. Now let's try the other option. Select Launch Column Selector and begin with no columns and select Include. We will select column indices as our next option. Here you have to provide index of a column that you want to put in dataset. You can also type multiple column indices. Let's take an example. We will include a few columns in the dataset now. Press OK and run the experiment. Let's visualize the output. As you can see, column number 1, 2, and 5 are there in the output. Now let's try the option column type. Here you can select type of columns that you want to include from the drop-down list next to it. It has following options that are numeric, integer, string, and double. I will select integer and press OK and run the experiment. And now we will visualize the output. So here is the output, which has 9 columns, and all the columns have the data type as integer. Now let's try the last option, that is all features. It will give the entire list of columns in the dataset. So let's press OK and run the experiment, and let's visualize the output. So it has all the columns, 26 columns in the output. So this is how select columns in dataset control works. Thank you.
Welcome to the Azure ML Toolbox series. Today I am going to talk about import data control. There are basically two ways to import data in Azure ML. The first one is internal source or local file, and the other one is external source or non-local file. So let's talk about import data from an internal source or local file. Let's go to the bottom left-hand corner of Azure ML Studio and click on New button. Then go to Dataset and select From Local File. Here you can choose your own file. So let's import Air Passengers file. airpassengers.csv dataset has been uploaded from my local machine to Azure ML Studio. If you want to upload updated version of an existing file, then you have to select this option which says this is the new version of an existing dataset, and the file name will appear in the text box given below. Next, we have to select a type for the new dataset. Following are the file types that are supported by Azure ML. You can choose any of the file type to upload your dataset. I have selected .csv format. Next, we have provide an optional description for dataset, where you can provide the description and press OK button. The file has been successfully uploaded to Azure ML Studio, and you can use this file by going to the left pane and expanding Save Datasets tab. Go to My Datasets and select airpassengers.csv and drag this on the canvas. So here we have the dataset which we have uploaded from the local machine. Now let's talk about import data from an external source or non-local file. There is another way to import dataset, which is by using import data control. To do so, go to Data Input and Output tab in the left pane and expand it. Select Import Data Control and drag this control on the canvas. This control is very useful when you have to import data from non-static file or external sources. Let's see different properties of import data control. The first parameter is data source, where we have 7 different types. The first type is web URL via HTTP. Let's talk about the first type. When importing data from an internal source or local file, I downloaded that data from a website and then uploaded it to Azure ML. But you can also directly import data from any website into Azure ML. Using this option, we just have to copy the URL of dataset from any website and paste it in the next text box which says data source URL. So let's go to a website. I will copy this link and paste it here. Here we have the URL of the website where the data resides. Next option is data format. Here we have 4 different data formats given in the drop-down list. The formats are CSV, TSV, ARFF, SVM Lite. Let's talk about them one by one. The first data format is CSV. It is a simple file format used to store tabular data such as spreadsheet or database. It is one of the most common file format. The second data format is TSV. These are essentially text files where raw data is stored and it can be viewed using any text editors or MS Excel. The next option is ARFF, which is Attribute Relation File Format. ARFF is an ASCII text file developed for machine learning projects. The file has a list of instances sharing a set of attributes. The last option is SVM Lite. It is an implementation of support vector machines in C language. It solves classification or regression problems. Depending on the format of the file, choose appropriate option among the 4. In this, we will select CSV as our dataset is in .csv file format. We must check the checkbox below which says CSV or TSV has header row because our dataset contains headers. The next option is Use Cached Results. This option must be checked if you want to cache the dataset for reuse on successive runs. When you check this option, the experiment will load the data the first time the module is run and thereafter use a cached version of the dataset. I will check this option. So we first have to run the module to be able to visualize it. We have finished running the experiment and let's visualize how the imported data looks like. Here we have imported data from airpassengers.csv which has 144 rows and 3 columns. The dataset has been successfully imported from a web URL via HTTP. Next, we will cover how to import data by using a Hive query. Let's go to Properties pane and select Data Source as Hive query. This option is used to read data from Hadoop clusters and HD inside distributed storage. Hive query is particularly useful for very large datasets. Next option is Hive database query. In this text box, you specify the data you want to read by using HiveQL. HiveQL is SQL-like query language. The query must return the data in tabular format. The query will be like select column list from table where expression. Below that we have hcatalog server URI. In this text box, you have to type the fully qualified name of your cluster. In Hadoop user account name, type the username that was used to create the cluster. Below that, Hadoop user account password is there. Type the password for respective account name. Below that, we have to mention location of output data. Select the option that indicates where the output data is stored. If you select HDFS, then it must be accessible by using same account name and password that you entered earlier. Also type HDFS server URI in the text box below. If you select Azure, then you have to type Azure account details like Azure account name, Azure storage key, Azure container name. Next option is Use Cached Results. Check this box if you want to use cached results of dataset. Once you are done with setting properties, hit Run at the bottom of the page. Let's talk about next data source, which is Azure SQL Database. This option enables you to use Azure SQL Database or Azure SQL Data Warehouse. In general, storing data in Azure databases is more expensive than using tables or blob in Azure. It may also limit the data you store in Azure depending on your subscription type. Storing data in Azure database is preferred if you need to be able to filter data before reading it, or if you want to save predictions or metrics back to the database for reporting. Let's see what options can be set for using Azure SQL Database. The first option is Database Server Name. Here type the server name that is generated by Azure. The next option is Database Name. In this field, we have to type the name of an existing database on the server you just specified in the above field. Below this, type username and password. The next option is Accept any server certificate. Check this option if you want to skip reviewing the site certificate before you connect and get data. But let me warn you, this is an insecure option. Below this, we have database query. In this field, type a SQL statement that describes the data you want to read. And check this option if you want to use cached results of the dataset. Let's take an example. My database server name is this, and my database name is. Now I will type my username and password. I won't select the option to accept any server certificate, and next I'll go to database query. Here I will type the database query to pull the data from this database. Once we are done with setting properties, hit run at the bottom of the page. I have finished running the experiment, and let's visualize the imported dataset. As you can see, we have successfully imported the data from Azure SQL Database. Next, we will cover how to import data by using Azure Table. The next data source is Azure Table. This is a data management service in Azure that can store large amounts of structured, non-relational data. It is a NoSQL data store, so let's see how to read data from Azure Table. Let's go to authentication type. There are two options, public or SAS, and the second one is storage account. Choose public or SAS option if you know that information is provided on public data source. Otherwise, select storage account. If you selected public or SAS option, then in table URI, type or paste the full URI that defines the account or public blob. If you select storage account, then you have to mention account name, which contains blob storage. Next is account key associated with the storage account. And for table name, type the specific name of the table that you want to read. Below this, we have an option called rows to scan for property names. This option lets you select how many rows should import data scan. There are two options, top n and scan all. If you select top n, then it scans specified number of rows starting from the top of the dataset. By default, 10 rows are scanned, but you can also specify a number in this field. This is helpful in large datasets. If you select scan all, then it scans all the rows in the table. Choose this option if the data is well structured. This ensures the integrity of your resulting property and metadata conversion. Check this option if you want to use cached results of the dataset. Once you're done with setting all the properties, hit run at the bottom of the page. Let's see the next data source, which is Azure Blob Storage. Azure Blob stores large amounts of data including binary data. Azure blobs can be accessed from anywhere by using HTTP or HTTPS. So let's see how to read data from Azure Blob Storage. Below this, we have authentication type. There are two options in this. Choose public or SAS option if you know that the information is provided on public data source. Otherwise, select storage account. If you selected public or SAS option, then in blob URI, type or paste the full URI that defines the account and public blob. If you select storage account, then you have to provide account name which contains blob storage. In the next field, type account key associated with the storage account. In the next field, type the name of the specific blob that you want to retrieve. You would specify the container and .csv file in this area. Next is blob file format. It indicates the format of the data that is stored in the blob so that Azure ML can process data appropriately. It supports a bunch of formats, that is ARFF, CSV, TSV, CSV with encoding, and Excel. We have already talked about ARFF, CSV, TSV in web URL data source. So let's talk about CSV with encoding. Check this option if your CSV file has been prepared with different field separator or strings. Let's go ahead and set following parameters. First one is column delimiter format. Choose between three different characters used as field separators provided in the drop-down list, which are comma, tab, and semicolon. Below that, we have encoding format. Choose the character encoding used by the file you want to read. There are a bunch of formats provided in the drop-down list. Let's talk about Excel blob file format. Choose this option to read data from Excel workbooks stored in Azure Blob Storage. Then below that, you have to specify Excel data format, which has two options, Excel sheet and Excel table. According to the option you selected in the earlier field, specify name of the worksheet or the table name in this text box. When you select spreadsheet, entire spreadsheet will be selected. You cannot specify the range of cells. You can check this option if your file has header row. And below that we have use cached results. Check this box if you want to use cached results of the dataset. Once you are done with setting all the properties, hit run at the bottom of the page. Let's talk about the next data source option, which is data feed provider. This option enables you to create an OData endpoint for a dataset where you can make your data model available for consumption via URL. You can also specify which operations are supported by OData endpoint. The next field is data content type. Here you have to select type of feed. Currently, only OData endpoints are supported by data feed providers. Below this, we have data source URL. Type the URL of a website that provides data in the required format. Select the checkbox of Use Cached Results if you want to use cached results of the dataset. Once you are done with setting all the properties, hit Run at the bottom of the page. Let's talk about the last option in data source parameter, which is on-premises SQL Server database. This option will help you to read data from an on-premises SQL Server database. Azure ML can access on-premises SQL Server database using Microsoft Data Management Gateway. So you must have Microsoft Data Management Gateway installed and registered beforehand. Next parameter is Data Gateway. Select the gateway that you created using Microsoft Data Management Gateway. Further, you have to enter database server name and database name in these fields. Going ahead, you have to enter your username, password, and database credentials. You can use Windows Integrated Authentication or SQL Server Authentication depending on how your on-premises SQL Server is configured. Next, type a SQL query in Database Query field which describes the data you want to read. You can select Use Cached Results if your dataset is not going to change in between execution of an experiment. Once you're done with setting all the parameters, hit Run at the bottom of the page. Importing data from an external source is really helpful when you have dynamic datasets. When a dataset changes, you can run the import data module individually and it will reflect updated data without affecting the other modules in an experiment. This is how import data control works. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Add Columns control in Azure ML. This control is used to add a set of columns from one dataset to another. Basically, it will concatenate columns of two datasets to create a single dataset. Before jumping to the Add Columns control, let's get two datasets on the canvas. For the demonstration purpose, I will be using saved datasets present in Azure ML. I have selected breast cancer info and breast cancer features datasets. Next, to use Add Columns control, go to Data Transformation tab and then Expand Manipulation tab and select Add Columns control and drag it on the canvas. Let's visualize both the datasets. This dataset has 102,294 rows and 12 columns. Breast cancer features dataset has 102,294 rows and 118 columns. Keep in mind, columns in each dataset must have an equivalent number of rows. If a number of rows are not equivalent among the two datasets, then use join data control, which supports outer joins on the common key column. We have equivalent number of rows in both datasets. As you can see, there are two input ports and one output port present in Add Columns control. There is a red mark which says input port left dataset is unconnected. So we will go ahead and connect the left dataset. Now it says input port right dataset is unconnected. So we will connect the right dataset. The datasets are connected and now we will run the experiment. The experiment has finished running and we can see the output results. Right-click on the output port of Add Columns control and select Visualize. If you remember, there were 118 columns in one dataset and 12 columns in another dataset, and resulting dataset has 130 columns. Therefore, the number of columns in the new dataset equals the sum of the columns of both the input datasets. Thus, we have concatenated two datasets. However, you cannot choose individual columns from input datasets to add in concatenated dataset. All the columns from each dataset are concatenated when you use Add Columns control. Therefore, if you want to add only a subset of the columns, use Select Columns in Dataset control to create a dataset with the columns you want. You can also save the new dataset generated from combining the two input datasets. To do so, right-click on the output port of Add Columns control and select Save as Dataset. A new window will appear where you can type the name of the new dataset and save it. This dataset will appear under My Datasets tab when you expand Save Datasets tab. Here is the dataset. If you want to concatenate columns of more than 2 datasets, then you can use more than one instances of Add Columns control. I will drag one more dataset on canvas. Here I have breast cancer data. Now I will drag one more instance of Add Columns control. Now I will connect the output of first Add Column control to the input of second Add Columns control, and the right input for second Add Columns control will be from breast cancer data. Let's run the experiment. The experiment has finished running, and let's visualize the results. As you can see, the total number of columns in output dataset is 140, which is the sum of the number of columns in 3 different datasets. Hence, we have successfully concatenated these 3 datasets. So, this is how Add Columns control works. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Add Rows control in Azure ML. This control is used to append rows from one dataset to the end of another dataset. I already have 2 datasets on the canvas. First one is MNIST Train 60K 28 by 28 dense dataset, and the other one is test datasets. Let's visualize these datasets. The train dataset has 60,000 rows and 785 columns. Let's visualize test dataset. The test dataset has 10,000 rows and 785 columns, which are common in test dataset as well as train dataset. Next, get Add Rows control on canvas, for which you want to go to Data Transformation tab and Expand Manipulation tab and drag Add Rows control on the canvas. As you can see, there are 2 input ports and 1 output port to Add Rows control. There is a red mark which says Input Port Dataset 1 is unconnected. So we will go and connect the dataset. Now it says Input Port Dataset 2 is unconnected. So we will connect the second dataset. Datasets are now connected to the input ports of Add Rows control. Keep in mind, to concatenate rows together, the rows must have the same schema. This means the same number of columns and the same type of data in the columns. Our datasets satisfy this condition. Now we will run the experiment. The experiment has finished running, and we can see the output results. Right-click on the output port of Add Rows control and select Visualize. If you remember, there were 60,000 rows in dataset 1 and 10,000 rows in dataset 2. The resulting dataset has 70,000 rows, which is the sum of the rows of dataset 1 and dataset 2. Thus, we have appended the rows from dataset 2 to the end of dataset 1. You must have noticed that you cannot filter the source dataset when adding rows. All the rows from both datasets provided as inputs are concatenated when you use Add Rows control. If you want to add only a few rows, use Partition and Sample control to define a condition to filter the rows and generate a dataset with only the rows you want. Add Rows control is useful when you have been working with different datasets and you want to combine the datasets to a single dataset. So this is how add rows control works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Summarize Data module in Azure ML. It generates a basic descriptive statistic report for the columns in a dataset. Summarize Data module can be used to create a set of standard statistical measures that describe each column in the input table. The module does not return the entire original dataset. Instead, it returns a row for each column, beginning with the column name and followed by the statistic for each column based on its data type. Such reports are useful when you want to understand the characteristics of the complete dataset. For example, you might need to know how many missing values are there in each column so that you can replace those missing values. Secondly, you might want to know how many unique categorical values are there in each feature column. Sometimes you want to make column categorical depending on the values it contains. For example, if your column contains only two values, survived and died, then you want to classify them so that you make them categorical. And lastly, you might want to know what is the mean and standard deviation of the column. So this helps in understanding the data. Also, you can output this statistic in a tabular dataset where you can use the data in BI reporting tools or provide the values as input to another custom operation in the experiment. So let's drag Titanic dataset and then drag Summarize Data module on the canvas and connect them. Once connected, then run the experiment. Now that's done, let's visualize the output of summarized data. Here you will see 23 columns which tells you the statistic of your data. But even if there are 23 columns, don't be afraid. There are just basically 4 types of statistic and different columns come under that. So understanding them is pretty easy. So the first type is counts, and there are 3 columns which come under count type. The first is count, second is unique value count, and third is missing value count. The second type is range, and under range we have min, max, and range column. The third type is statistical summaries. Under that we have mean, mean deviation, mode, sample variance, sample standard deviation, sample skewness, sample curves. Fourth type is percentiles. So under that we have first quartile, third quartile, then 0.5 percentile, 1 percentile, 5 percentile, 95 percentile, 99 percentile, and 99.5 percentile. So in the first column feature, all the column names have been listed. Second column is count. It has listed count of records present in that particular column. Next is unique value count. From this column, we can decide whether we can make any column categorical or not. So let's see, passenger ID has 891 rows, so we can't make it categorical. Survived, P class, sex, and embarked has very few values, so they qualify for categorical values. So the next column is missing value count, and it tells us about the missing values in a particular column. So we have got missing values in age column, cabin column, and embarked column. So we want to treat them in some or the other way. Cabin column has 687 missing values, so large portion of that column is not available. So even if we replace missing values, it would not be very accurate. So better drop that column. So likewise, you can visualize all the statistic and using some control like edit metadata, clean missing values or missing value scrubber, you can treat them. This control is very useful for analyzing data. So this is how you can make use of summarized data control. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Remove Duplicate Rows control in Azure ML. This control is used to remove all the duplicate rows from the input dataset based on the list of features or columns you specify. Before jumping to the Remove Duplicate Rows control, let's get a dataset which has a lot of duplicate values. I will take a dataset from Saved Datasets. Let's drag Restaurant Ratings dataset on the canvas. Next, to use Remove Duplicate Rows control, go to Data Transformation tab and expand Manipulation tab. Drag Remove Duplicate Rows control on the canvas. But before removing the duplicate rows, we have to understand which columns have duplicate values. So let's visualize the dataset. This is the restaurant ratings dataset. It has 1161 rows and 3 columns. So we have to determine duplicate rows, but there is no parameter that indicates duplicate values in a column. However, we can determine unique values in a column, and based on that, we can calculate the duplicate rows in it. To check the number of unique values in a column, we have to click on the column name, and on the right hand side, we can see unique values under Statistics pane. User ID column has 138 unique values and all the other data is duplicated. Similarly, Place ID column has 130 unique values and all the other data is duplicated. And in ratings, there are only 3 unique values. Going ahead, let's talk about Remove Duplicate Rows control. We have to connect this dataset to Remove Duplicate Rows control. In the Properties pane, we have to select columns from which we will remove the duplicate rows. Let's go there and click on Launch Column Selector. I will select User ID column, and by using Remove Duplicate Rows control, we will be able to remove duplicate rows from this user ID. I've selected user ID because user ID is the key column, and therefore if we remove duplicates from that column, then the number of entries in other columns will also be reduced. And then you can also remove duplicates from other columns as well if you want. If the dataset has any missing values, then there are some additional conditions that may apply. So let's see our dataset one more time. User ID column has 0 missing values, Place ID column has 0 missing values, and similarly rating column has 0 missing values. So this dataset doesn't have any missing values, but your dataset might have some missing values, and in that case you have to keep 3 conditions in your mind. The first condition is the input dataset is allowed to have missing values in key and non-key columns. The second condition is for key columns, a missing value is considered equal to the other missing values but not equal to non-missing values. And the third condition is an exception is made when values are missing in key columns in sparse datasets. In a sparse dataset, the missing value is considered equal only if it equals the default representation of a sparse value. Next, we have an option to retain first duplicate row. This option is selected by default and I'll keep it as it is. Now we will run the experiment. Experiment has finished running and we can see the output results. right-click on the Remove Duplicate Rows control and select Visualize. If you remember, there were 1,161 rows in the restaurant ratings dataset, and after applying Remove Duplicate Rows control, we have 138 number of rows in the output dataset. Let's click on User ID column and we can see there are 138 unique values. Therefore, we have removed all the duplicates from User ID column. And this is how Remove Duplicate Rows control works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about missing value scrubber control in Azure ML. This is one of the most important control you want to utilize when you pre-process your data. It provides some basic methods for handling missing values. It expects a dataset as input and it returns a dataset with missing values that are substituted by a method that you select. So missing values can be handled in multiple ways, but the method you choose will be applied to the entire dataset. So if you want to treat some of the columns by using missing value scrubber, then use select columns in dataset control. Then select a few columns and apply missing value scrubber methods on those selected columns only. For that, we first have to understand the dataset and see what columns consist of missing values. So I have adult census income dataset on the canvas. Let's visualize it. I will check each column one by one to see if it has any missing values. When I click on any column, some statistics will appear on the right hand side. Here we will know if it contains some missing values or not. As you can see, age column consists of 0 missing values. So we don't want to apply missing value scrubber control on age column. Let's go ahead and see the second column, which is work class. So this column consists of 1,836 missing values. So we want to apply missing value scrubber on this column. Likewise, I already have a list of columns from this dataset which contains missing values. And I have selected only those columns by using select column in dataset control. So work class, occupation and native country are 3 columns which had a lot of missing values. Now we have to treat all this missing data. You can do a bunch of things if you go to Properties pane of Missing Value Scrubber. The first thing that you have to do is to choose a method from this drop-down list for treating missing values. Currently, we have selected Custom Substitution method. The next parameter is Replace with Value. This parameter is specific to Custom Substitution Value method. We have to type a replacement value for all the missing values in this text box. If you specify a floating point value to replace missing values in a column of integers, the value substituted will be converted to the nearest integer. I will keep 0 in this field. The next parameter is columns with all MV. From this drop-down list, you can choose whether to keep columns or remove columns which contain all the missing values. I will select Keep Columns option here. And the last parameter is Missing Value Indicator column. From this drop-down list, you can choose whether to generate missing value indicator columns or not. I will select this Generate option, which is over here, and now I will run the experiment. So let's see the output. Azure ML has generated 3 additional columns to indicate whether that particular column contains missing values or not. If the column had any previous missing values, then it will be marked as true, otherwise false. So let's find out what values were missing. So this is native country is missing column, and here it is marked as true. So in native country column, the value is replaced by 0. Likewise, it has replaced all the missing values in the dataset by zeros. The next method in missing value scrubber is replace using mice. The long form of mice is multiple imputation by chained equations. This method initializes the missing entries with a default value. Then it updates each column by using an appropriate regression or classification algorithm. These updates are repeated a number of times as specified by the number of iterations parameter. We have already talked about these two parameters. So once you're done with setting all the properties, you can hit run at the bottom of the page. I'll go ahead and talk about rest of the methods in missing value scrubber, but before that, I need numeric columns to perform those operations. So I have this save data set which contains age column which has a lot of missing data and it is a numeric feature. This is the age column which contains 177 missing values. So I will be applying rest of the missing value features on age column. I've selected age column in select columns in dataset control as well. In missing value scrubber, select replace with mean option. Use this option if you know that missing values would be approximately same as the rest of the values. It calculates mean of all the values in a column and assigns replacement value to any missing value in every column with a data type of integer, double, or boolean. Now run the experiment. Let's visualize the output. An age is missing column. This row is indicated by true, which means that the corresponding value in edge column was missing initially. Therefore, Azure ML has calculated mean of all the values in edge column and it has been assigned to all the missing rows. The next option in missing value scrubber is replace with median. It assigns the median of a column to any missing value in every column with a data type of integer or double. I will keep both these entries as it is and I'll run the experiment. Let's visualize the output. In age is missing column, this entry is marked as true, which means that the corresponding entry in age column was missing initially and now it has been assigned with a value of 28. Since the median of this column is 28 and therefore wherever there are missing values, 28 is assigned to it. Moving ahead, the next option in missing value scrubber is replace with mode. It assigns the mode of the column to any missing values in every column with a data type of integer, double, boolean, or categorical. I'll keep these two parameters as it is and I'll run the experiment. Let's visualize the output. In age is missing column, this entry is marked as true, which means that corresponding entry in edge column was missing initially and now it has been assigned a value of 24. The mode of this column is 24 and wherever there are missing values, 24 is assigned to it. And the last option in missing value scrubber is remove entire row. It removes all the rows in the dataset with one or more missing values. This is useful if the missing value can be considered as missing at random. I will keep rest of the settings as it is and run the experiment. Let's visualize the number of rows in the original dataset. It has 891 rows. Now we will visualize the number of rows in missing value scrubber's output. It has 714 rows, which means that 177 rows containing missing values have been removed from the dataset. So before choosing any method from missing value scrubber, you have to analyze your data. You can choose replace with median if your dataset has a large number of outliers. You can choose replace with mean if your values are very close to each other. So it actually depends on your dataset. And this is how missing value scrubber control works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Enter Data Manually control in Azure ML. This control enables us to enter and edit small datasets by typing values. You can use Enter Data Manually module to create a small single column dataset by typing values rather than loading data from different sources in Azure ML or from a local file. So this control can be helpful in following scenarios. The first is generating a short list of values for testing. Second is creating a shorter list of labels for use with the group categorical values or execute R script modules. Third is entering values for use in apply math operation or replacement values for use in replace discrete values. And the last is typing a list of column names to insert in a dataset. This is just the snippet of the dataset that I have. So I have a dataset of a company where each customer has been assigned a space ID which indicates the place where they sit in the company. Basically, there are 6 types of spaces in total. Therefore, I want to know the names of these spaces from the lookup table. So rather than uploading the lookup table, we can just create the table which just has 6 rows. So let's drag Enter Data Manually control on the canvas. In the properties pane of this control, CSV format is selected by default. You can select any other format depending on your dataset and requirements. It supports bunch of other formats as well. For example, ARFF, CSV, SVM Lite, and TSV. If you don't know what each of these format means, then you can watch video tutorial of import data control where I have described each of these formats in detail. Here I have selected CSV format. After you select appropriate file format, then check the checkbox of Has Header, which indicates whether your dataset contains any headers or not. If you don't select this option, columns would be named as column 1, column 2, column 3, etc. You can then use Edit Metadata to change the column names. But if you know your column names, then you should write it in the dataset. A text box called Data is given below to enter the data. Type the data values according to file format you have selected. I have selected CSV, so I will type all the values separated by comma. You have to press enter after typing the last row. If you press enter multiple times to add multiple empty trailing rows, the final empty row will be trimmed, but other empty rows will be treated as missing values. You can enter rows with missing values and then go back and edit the rows to add values later. Now you can run the experiment. Experiment has finished running and we can visualize the new dataset by right-clicking on the output port of Enter Data Manually control and select Visualize. As you can see, the dataset has been created. It has created 2 columns. First is Space ID. So it should be an identifier and not a numeric feature, but by looking at the values, Azure ML treated them as numeric values. We can remove this numeric feature by using Edit Metadata. The second column is Space Name. So this column should be treated as string feature, and yes, it has been treated as string feature only. So everything is good here. You can also save this dataset by right-clicking on the output port of Enter Data Manually control and click on Save as Dataset. So here you will be prompted to save the dataset. And this will be saved under Save Datasets and My Datasets tab. So this is how Enter Data Manually control works. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about Edit Metadata Control in Azure ML. Edit Metadata Control is used to change the metadata associated with columns in the dataset. It does not change the data type or values in the data, but the metadata inside Azure ML, which tells downstream components how to use the columns. Here I have listed changes made by this control to our data. The first one is treating Boolean or numeric columns as categorical values. Second one is you can mark a column as class label. This is used for prediction. Third one is you can mark the columns as features. So basically, this control can be used where we have to manipulate the definition of the columns to meet requirements of downstream module, since some modules can only work with specific data types or specific category of the data. Once you have performed the required operation for underlying module, you can reset the metadata to its original state. Now let's see how to configure Edit Metadata Control. To do so, get Edit Metadata Control and the dataset on the canvas and connect them. I have Titanic dataset on the canvas and I have connected it to the Edit Metadata Control. So let's understand Edit Metadata first and then see how we can use it for our dataset. Here we have to select columns by using Launch Column Selector. Note that Edit Metadata will apply changes to all the columns in selection. So if you want to configure two columns of the same dataset differently, then use two Edit Metadata modules for different types of transformations. Below the list of selected columns, we have an option to select the data type for the selected columns. If you want to assign a different data type to the list of selected columns, then use this option and select the data type. The data types supported are string, integer, floating point, boolean, date time, and time span. If you do not specify a new data type, the column metadata is unchanged. The change of data type occurs only on the metadata and not on the original columns of the dataset. You can then recover the original data types by using Edit Metadata to reset the column data type. The next option is categorical, where you can make columns categorical or non-categorical, or you can select unchanged to keep the columns as it is. If you select to make columns categorical, then they would be treated as categories and not as results, scores, labels, or other values. For example, if you have a column containing values 1 and 0, and if you know that these values represent some binary variable such as if a customer is churner or non-churner, then we should flag them as categorical. As a result, the other values in table would be categorized based on these binary variables. And also, it prevents machine learning algorithms from treating 0 and 1 as numeric values rather than categorical values. After this, we have an option called Fields. Use this option if you want to change the way that Azure Machine Learning uses the data in the model. There are a bunch of options provided here. The first option is Features. By using this option, you can flag your column as feature because some modules require columns to be features. The next option is Label. By using this option, you can mark a column as label. This is required in some modules where at least one predictable attribute should be present in the dataset. After that, we have weight. This option should be used with numeric data to indicate that column values represents weights for use in machine learning scoring or training operations. Only one weight column can be present in an entire dataset, and the column must be numeric. Below this, we have 4 options, and all the 4 options can be used to clear previous selections and restore metadata to the default. So clear feature would remove the feature flag from the column. Clear label is used to clear label metadata assigned to the column. Clear score removes the score metadata from the column, but there is no option to specify a column as score, and it is going to get added in Azure ML soon. Clear weight would remove the weight metadata from the column. So this way you can reset the original columns to original data types. In the next field, you can rename the columns. To rename multiple columns, type the names as a comma-separated list in order of the column indices. All selected columns must be renamed. You cannot omit or skip columns. So let's see how to configure Edit Metadata for our dataset. We have Titanic dataset connected to Edit Metadata. So let's visualize it. So the first column is passenger ID, which indicates the identification number assigned to each passenger. The next column is survived. Survived is a numeric feature, but it has only two unique values, 0 and 1, which indicates whether that person has survived or not. So we can convert this to categorical. The next column is P class, which indicates the passenger class, and there are only three unique values, which means that there are three different passenger classes available. So we can convert this to categorical form. Likewise, sex column has two unique values, male and female. So let's convert this to categorical form, and we will change the names of these columns as well. Let's go to launch column selector to select the columns survived, P class and sex, and then press OK. Now we want to make these columns as categorical. So I'll go to categorical tab and select make categorical option. After that, we can give new names to all the columns that we have selected. Even if we are not changing names of other columns, we have to list them since we cannot skip any column name. So now let's run the experiment. Experiment has finished running, and now we can visualize the output dataset. So survived column is now converted to categorical feature from numeric feature. The name of P class has been changed to passenger class, and now it is marked as categorical feature. Sex column is now marked as categorical feature as well. So there are two more columns which are unclear by its name, which are SIB-SP and PARCH. But we don't want to make them categorical, so we did not select them in the previous edit metadata control. So we will drag one more instance of edit metadata and then select those two columns as well. So we will go to source location of our dataset to understand the meaning of SIB-SP and PARCH. So here they have given the variable descriptions, and you can see SIB-SP and PARCH column names. So what is SIB-SP? It is number of siblings / spouses abroad, and PARCH is number of parents / children abroad. So now we know what is the meaning of SIB-SP and PARCH, therefore we will name these two columns appropriately. So now in the launch column selector, we will select SIB-SP and PARCH and press OK. And I just want to change the column names. Now we can run the experiment. Our experiment has finished running, so let's visualize the output of second instance of edit metadata. As you can see here, SIB-SP is now changed to sibling spouse and PARCH is now changed to parent child. Hence the names are changed. So you can just play around with all these parameters of edit metadata to understand them better. So this is how edit metadata works. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today you will learn how to use Apply SQL Transformation module to specify a SQL query using SQLite syntax to work with the values of input datasets. SQL statements are very useful when you have to modify some data for use in other environments. For example, if you want to create tables for results and save the datasets in a portable database, then you can do that with Apply SQL Transformation. Also, you can perform custom transformations on data types or create aggregates. This control allows you to execute SQL query statements to filter or alter data and return the query results as a data table. So let's see how to configure Apply SQL Transformation. There are three inputs, so it can take up to 3 different datasets as input and produces a single dataset as resulting output dataset. These input datasets are referenced as T1, T2 and T3 with respect to the index of the input port. So the next part is write a SQL query which uses SQLite syntax. When typing multiple lines in the SQL script text box, use semicolon to terminate each statement. Otherwise, line breaks are converted to spaces. So the next part is to drag movie ratings dataset on canvas and connect it to apply SQL transformation control. This dataset would be referred as T1. So let's visualize this data first. So it has user ID, movie ID, rating, and timestamp columns. I want movie IDs with rating 10. So let's go to Properties pane of Apply SQL Transformation Control and write a SQL statement. So I want to retrieve all the columns from movie ratings whose rating is 10. Also, these ratings are given by user, so multiple users have rated one movie. I just want those movies for which at least one rating is 10. So I will use group by clause on movie ID. So let's type the query here. Once you're done with writing the query, you can go ahead and run the experiment. Experiment has finished running, so let's visualize the output results. So these are the results of our query. We have all the movie IDs with rating 10. Likewise, we can attach two more datasets. So I will drag movie tweets dataset and IMDb movie titles dataset. And let's connect them to apply SQL transformation. So let's visualize movie tweets dataset. In this dataset, we have tweet ID for tweets posted by various users. So we will just retrieve tweet ID from this dataset, and it also has movie ID to join with T1. Now let's visualize IMDb movie titles. So IMDb movie titles dataset has movie IDs and movie names. So I will join these three datasets on movie ID, and from this dataset I will retrieve movie name. Now click on Apply SQL Transformation and write a SQL statement in SQL query script. I have already written the query and I am retrieving movie ID, movie name, rating and tweet ID from these three tables. So once you are done with writing the query, then you can run the experiment. Let's visualize the output results of Apply SQL Transformation. Here we have movie ID and its name with respective rating and tweet ID. And we have retrieved all this information from three different tables having rating 10. So Apply SQL Transformation supports most of the complex queries, but it does not include many features supported by commercial relational database systems. For example, left outer join is implemented, but not right outer join or full outer join. Also, you can create a view within SQLite, but thereafter views are read-only. You cannot execute a delete, insert, or update statement on a view. However, it is very useful module to transform data in other environments. So this is how Apply SQL Transformation module works. Thanks for watching.
Hello everyone. In this video, I'm going to talk about split data control in Microsoft Azure Machine Learning Studio. I have my dataset and necessary module ready over here, for which you can watch previous video tutorials. So, as the name indicates, split data control is used to split the data into parts. By default, split data control will divide the input into two equal parts. These two distinct sets will be used as training and testing sets. Now let's get split data control on canvas. Go to the left pane and expand data transformation tab. In that, look for sample and split and expand that tab. There is a split data control. Drag this control on the canvas. Now I will join the output of previous module to the input port of split data so that split data module can access the dataset. Now let's look at the properties pane of split data. So let's look at the splitting mode parameter. It has 4 options which are split rows, recommender split, regular expression, relative expression. Let's look at each of them one by one. The first option is split rows. This option divides source data into 2 equal and distinct datasets. However, you can also specify the percentage of data to be divided into each set. This can be achieved by modifying entry in the next row, which is fraction of rows in the first dataset. The ratio should be a number between 0 to 1, which indicates percentage of rows present in the first output dataset. For example, if you type 0.6, then dataset would split into 60:40 proportion, with 60% of the rows will be sent to the first output dataset and the 40% will be sent to the other output dataset of split data control. Then there are 2 options to perform the split, which are randomized split and stratified split. So let's see what randomized split is. This method is used when you don't want to preserve any order of the data. It is useful when you have discrete data and you want similar data in training as well as test datasets. Generally, this option is preferred when splitting dataset into training and test datasets. If you want to perform randomized split, then check the checkbox in front of it. Below that, you have an option to mention random seed, which is a numeric value. So if you want to perform randomized split, then you have to mention random seed value. So let's see what is random seed. Random seed is used to indicate pseudo-random sequence of instances to be used. In simple words, if you want to repeat the results of a split operation, you should specify a seed for the random number generator. If you mention 0 in this field, then seed value is generated by using system clock. As a result, split operation will give slightly different output every time you run the module. Now let's look at the other option, that is stratified split. In this, you select a target column for which you want results to be assigned equally among the 2 resulting datasets. If you set this option to true, then both the output dataset will have the strata column. You can select which column has the values to stratify on or simply group on. If your column has too many unique values, then this functionality won't work for that. In stratified sampling, the data is divided in such a way that a percentage of each target column value is put in each output dataset. The working is somewhat similar to group by query in SQL. For example, you might want your dataset to be balanced by age, income, or gender, etc. To select a column for stratified split, an option is given below, stratification key column. This option will contain the name of the column to perform stratification split by. Click on the launch column selector to choose the column. To learn how to use launch column selector, please watch video tutorial on select column in dataset control. Now let's run the experiment and visualize the output. We have finished running the experiment and let's see the output of dataset 1. We have used MEC column as the stratification column, and as you can see, the output is organized by using MEC column. This is the output of dataset 2, and as you can see, this output is organized by using MEC column. Generally, it is advisable to select randomized split to produce unbiased results. So let's take an example of that. Let's put 0.8 in fraction of rows in the first output dataset field, which will divide the dataset into 2 parts one containing 80% of the dataset and another part contains 20% of the entire dataset. We have checked the randomized split checkbox and mentioned random seed as 0 and stratified split to false. And now let's run the experiment. We have finished running the experiment and let's visualize the data on both the output ports of split data control. This is the output of dataset 1. There are 8 columns and 164 rows and the data is randomized. This is the output of dataset 2. We will use this dataset as test dataset. It has 41 rows, 8 columns and the data is randomized. Now let's see the other splitting mode option, which is regular expression. Here you have to type a regular expression. When regular expression is executed on dataset, the dataset will be divided into two parts. The first dataset will have the rows with values that match the regular expression, and the second dataset will contain all the remaining rows. It can also be applied to specific columns in dataset. For example, let's write a regular expression for separating dataset based on a column name make. So the first dataset will contain all the rows where the make column begins with one of these characters, that is A, B and C, and the second dataset will contain all the remaining data. Now let's run the experiment and visualize the output. So this is the output of dataset 1, which has 21 rows and 8 columns, and make column has all the entries starting with A, B and C. This is the output of dataset 2, which contains 184 rows, 8 columns and has all the remaining data. Now let's look at the other splitting mode, which is relative expression. Here we have to type an expression that performs a mathematical comparison. When a relative expression is executed on dataset, the dataset will be divided into two parts. The first part will contain rows with values that match the relative expression, and the second will contain all the remaining rows. It can also be applied to specific column in dataset, but there are some restrictions when using relative expression to split dataset, which are as follows. First is columns must be numeric. Date-time data type is also supported. Second is it can reference a maximum of one column name. Third is you can use all the relational operators in this area. Fourth is you cannot use a pair of parentheses to group operations. For example, let's divide the dataset by price of cars. We will write a relative expression that will divide dataset into two parts. The first part will have all the cars whose price is less than $7,000. The second part will contain all the remaining data. Let's run the experiment, and after that we can visualize if the results matches with the relative expression or not. Here is the results for dataset 1, which has 36 rows and 8 columns, and the price column has all the entries less than 7,000. This is the output of dataset 2, which has 169 rows, 8 columns, and in price column all the entries are greater than 7,000. Now let's look at the last splitting mode, which is recommender split. Recommender split is used when splitting or preparing data for recommendation model. If you split data for recommendation model, it will return two data sets, a training set and test set. If the input data contains any extra data per instance, such as ratings or price, then it is preserved in the output for prediction. There are 8 options that can be applied on datasets simultaneously, which are as follows. The first one is fraction of training only users, which indicates the fraction of users that can be assigned only to the training dataset, which means that they can never be used to test the model. Let's put 0.8 in this field, which means that for 80% of the users, we will use all the ratings to train the model, and we will keep remaining 20% of the ratings for testing purpose. The second option is fraction of test user ratings for training. It indicates a portion of the user ratings that has been collected to be used for training. We will put 0.2 here, which means for each user in the test group, we will hold out 20% of that user's rating for training the model. The requested fraction of test user ratings for training is moved to the training set, while the rest is moved to the test set. It ensures that at least one instance is always moved to the training set for each user. Before jumping to the next parameter, let me explain you what cold start is. Cold start is a situation when a recommender system does not have any historical information about user or item and is unable to make any personalized recommendations. Cold start is the worst nightmare of any recommender system researcher. Therefore, we want to avoid such data. Now let's go to the third option, which is fraction of cold users. These type of users has not been previously encountered. The system has less information on these users, even if they might be valuable for training, but predictions might be less accurate. We will put 0 in this field as we want our results to be more accurate. Now let's move to the next option, which is fraction of cold items. These type of items has not been previously encountered. The system has less information on these type of items, even if they might be valuable for training, but predictions might be less accurate, and we will put 0 in this field as well because we want our results to be more accurate. Further, we have fraction of ignored users. Recommender splitter can ignore some users, which enables you to train model on a subset of data. This might be helpful in performance reasons. In this field, you can mention the percentage of ignored users. As for now, we will train the model on full dataset, so put 0 in here. Next is fraction of ignored items. Recommender splitter can ignore some items, which enables you to train model on a subset of data. This might be helpful in performance reasons. In this field, you can mention the percentage of ignored items. Same as ignored users, we will train the model on full dataset, so put 0 in here. The next option is remove occasionally produced cold items. An item is said to be occasionally cold if it is discovered by the test set and it was not explicitly chosen as cold. Such items can be produced after performing step 4, fraction of cold items, and step 6, fraction of ignored items in recommender splitter. This option can be used to keep requested number of cold users and items set to 0. This ensures that all the entities in test set are included in training set. So let's check the checkbox. The last option is random seed for recommender. By default, the input data will be randomly split every time, but if you want the same data every time you run split data model, then you have to specify a seed value in this field. Let's put 0 in here as we don't want the dataset to be exactly same every time. Now we will run the experiment and visualize the output. This is the output of dataset 1, which has these many rows and 3 columns. This is the output of dataset 2, which has these many rows and 3 columns. This is how we can use split data control to split the data into training set and test set. Thank you.
Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about partition and sample control in Azure ML. This control creates multiple partitions of a dataset based on sampling. This control is very useful when dividing your data into multiple subsections of the same size or separating data into groups and then working with data from a specific group. It can also be used for sampling and creating a smaller data set for testing. So let's see how to configure partition and sample control to perform these tasks. The first mode in partition and sample is assign to folds. This is used to split data into partitions. Now I will connect the dataset to the input port of partition and sample control. Automobile price data has been connected to the control. So by using assign to folds method, you can divide the dataset into subsets of the data. You can also create a custom number of folds for cross-validation. Now let's go to the properties pane of partition and sample control. Check the use replacement in the partitioning option if you want the sampled row to be put back into the pool of rows for potential reuse. As a result, the same row might be assigned to several folds. But if you don't select this option, then each row will be assigned to exactly one fold. I won't select this option. Then select the option Randomized Split if you want the rows to be randomly chosen. If you do not select this option, rows are assigned to the folds by using round robin method. This option is selected by default. For random seed, type an integer to use as a seed value. This option is important if you want the rows to be divided in the same way every time. Otherwise, the default value of 0 means a random starting seed will be used. Below that, specify the partitioner method, which has two options: partition evenly and partition with customized proportions. If you select first option, an equal number of rows are assigned to each partition, and then specify the number of folds to split evenly in the text box given below. If you select second option in partitioner method, then provide a comma separated list that indicates the size of each partition. You can type the partition sizes by clicking on the text box given below. For example, I will divide the data into three partitions. The first partition will be 0.6, the second partition will be 0.2, and the third partition will be 0.2. Keep in mind that sum of all the partition sizes must add up to exactly 1. If it is less than 1, Azure ML will create one extra partition automatically, and if it is more than 1, an error will be raised. Below that, select the option Stratified Split if you want the rows to be stratified when split. If you choose this option, you have to select a strata column. Click on Launch Column Selector to select the strata column. I'm selecting Price column as the strata column. And now run the experiment. The green tick mark ensures that the module outputs multiple datasets partitioned using the rules you specified. To verify if the data is properly sampled into partitions, we have to configure the next option in partition and sample, which is pick fold. If you want to use data from a predefined partition, then choose pick fold option from partition and sample mode. You must have two partition and sample controls for this. The previous partition and sample module must have used assign to folds option to generate some n number of partitions. In our case, we have created 3 partitions. In the second partition and sample control, select pick fold mode. In specify which fold to be sampled from, select a partition to use by typing its index. Indices are 1 based. For example, if you have divided the dataset into 3 parts, the available indices would be 1, 2, and 3. You can also type the index of a certain fold and then select the option Pick complement of the selected fold to get everything but the data in the selected fold. If the previous instance of the partition and sample module created multiple partitions, you can connect additional copies of the partition and sample module to handle each partition. I will get 2 more partition and sample controls to show 3 different partitions. In the first partition and sample control, I have index as 1, which would have partition of size 0.6. Let's comment on this control so that we don't create any confusion afterwards. You can add the comment to a control by double clicking on it and write the comment here. Partition size 0.6. Similarly, for this partition and sample control, I will select pick fold and then I will type second index here, which will hold the partition size 0.2. So I will comment it here, partition size 0.2. Similarly, for this partition and sample, I will select pick fold and type index 3 over here, which would hold partition size of 0.2, and I'll comment it over here. In order to see the three different partitions created by first partition and sample control, we will connect the output of first partition and sample control to these three partition and sample controls. And run the experiment. Each control outputs a single dataset containing only the rows assigned to that fold. So let's see the output of the first partition size. This is the 60% of automobile price data, which have 188 rows. The second partition contains one row, which is 20% of the partition size, and the third partition size was also 0.2, which is 20% of automobile price data, and it has 16 rows. The difference between the second and third partition is because we have selected the strata column as price in the first partition and sample control. So if we don't select any strata column, then let's see how the output looks like. So let's see the output of first partition. It contains 123 rows, which is 60% part of automobile price data. The second partition contains 41 rows, which is 20% of the automobile price data. And third partition contains 41 rows, which is 20% of the automobile price data. Moving ahead, let's see the next option of partition and sample control, for which I will delete all these partition and sample controls. The next option is head. This will give you only the first n rows from the dataset. This option is useful if you want to test an experiment on a small number of rows and don't need the data to be balanced or sampled in any way. Below that, type the number of rows to select. I will type 5 over here. It should return 5 rows. Now run the experiment. This option outputs a single dataset containing only the specified number of rows. The rows are always read from the top of the dataset. So let's verify this. We can see that the result contains only 5 rows. Now let's talk about the last option in partition or sample mode, which is sampling. With this option, you can perform simple random sampling or stratified sampling. This is useful if you want to create a smaller representative sample dataset for testing. Below that, we have to mention rate of sampling. Type a value between 0 and 1 that indicates the percentage of rows from the source dataset that should be included in the output dataset. I will type 0.5 here, which means the sampling rate should be 50%. The rows of the input dataset are shuffled and selectively put into the output dataset according to the specified ratio. For random seed for sampling, type an integer to use as a seed value. This option is important if you want the rows to be divided in the same way every time. Otherwise, the default value of 0 means that a random starting seed will be used. Select stratified split for sampling if it is important that the rows in the dataset should be divided evenly by some key column before sampling. If you choose true, then you will have to select a strata column like we did in the assign to folds method. I will select false option in this field and run the experiment. Let's see the output results. There are 103 rows in the output, which means we have 50% of the data in the output. So this is how partition and sample control works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about two-class boosted decision tree algorithm. And my main focus in this video is to explain how to configure the parameters of decision tree and read the output of decision tree. So let's get started. Two-class boosted decision tree is based on boosted decision tree algorithm. A boosted decision tree is an ensemble learning method in which the second tree corrects for the errors in the first tree, the third tree corrects for the errors in the first and second trees, and so forth. Predictions are based on the entire ensemble of trees together that makes the predictions. It is easy to configure and learn and also gives top performance on wide variety of machine learning tasks. However, it is one of the most memory intensive learner and therefore boosted decision tree might not be able to process very large amount of datasets that some linear learners can handle. So let's see how to configure this algorithm. Here I have my experiment ready for demonstration. I have used Titanic dataset in this experiment and I want to predict which people might survive and which would not. And then I have pre-processed the data and selected those columns which would mostly affect the survival of people on Titanic. And after that I have used split data to partition data into training and test set. Then I have trained the model using two-class boosted decision tree algorithm, and for training I have used tune model hyperparameters control. Further, I have scored the model and then I have evaluated the results. So let's focus on two-class boosted decision tree algorithm. In the first parameter, you have to specify how you want model to be trained by setting the create trainer mode option. You have to select parameter range when you're not sure of the best parameters. You can find the optimal parameters by specifying multiple values. The trainer will iterate over multiple combinations of the settings you provided and determine the combination of values that produces the best result. I have selected parameter range in my case. Otherwise, single parameter is selected. You can choose this option if you know how you want to configure the model. You can provide a specific set of values as arguments. But for now, I will select parameter range. Next is maximum number of leaves per tree. It indicates the maximum number of terminal nodes that can be created in any tree formed by the model. You can increase this value to get better precision and you potentially increase the size of the tree. But there is a high risk of overfitting and longer training time. I have kept the default values here. You can also use range builder to specify a range of values here. After that, we have to specify minimum number of samples per leaf node. It indicates the number of cases required to create any terminal node in a tree. By increasing this value, you increase the threshold for creating new rules. For example, with the default value of 1, even a single case can cause a new rule to be created. If you increase this value to 5, the training data would have to contain at least 5 cases that meet the same conditions. Therefore, I have mentioned 1, 10, and 50 in this field. Next parameter is learning rate. So what is learning rate? The learning rate determines how fast or slow the learner converges on the optimal solution. If the step size is too big, you might overshoot the optimal solution. If the step size is too small, training takes longer to converge on the best solution. Therefore, type a number between 0 and 1 that defines the step size while learning. The next field is number of trees constructed, which indicates the total number of decision trees to create in the ensemble. This value also controls the number of trees displayed when visualizing the trained model. If you want to see or print a single tree, then you can specify value 1 in this field. However, this means that only one tree will be produced and n further iterations will be performed. By creating more decision trees, you can potentially get better coverage, but training time will increase. Therefore, I have mentioned values till 500 over here. You will have to play around with these parameters depending on your dataset to get the best model results. You can set the random number seed after that. I have kept 0, which means that initial seed value is obtained from the system clock. After this, you can just train the model by running the experiment. In my case, I have selected parameter range in create trainer mode option, and that is why I need to use tune model hyperparameters instead of train model. If I would have chosen single parameter option, then I would have used train model control. So now let's run the experiment. Our model is now trained, so I will go ahead and right click on Tune Model Hyperparameters Control to see the tree that was created on each iteration. You can also click on each tree to drill down into splits and see the rules for each node. In the top left corner, it tells us how many trees have been created. So in our case, 35 trees have been constructed. So you can click on each tree that is generated, and then you will be able to click on each branch to see the breakdown and the prediction results as well. So 1 means that person on the Titanic survived, and 0 means that person did not survive. On the left hand side, you will be able to see all the trees that are generated by trained module. And when you click on one tree, then you will be able to click on the leaf nodes where you can see how the trained model got those results. In this case, trained module compared all these 3 features and then it predicted this 0 value, which means that the particular person did not survive. So this is how we configured 2 class boosted decision tree algorithm and learned how to generate trees using that. In the upcoming video tutorial, you will learn how to evaluate the results generated by decision tree. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about join data control in Azure ML. This control is used to join 2 datasets. You can perform a join operation on 2 tables by using this control. To perform join, we have to get 2 datasets on the canvas. For demonstration purpose, I will be using saved datasets in Azure ML. I have selected restaurant customer data and restaurant ratings dataset. Next, to use join data control, go to data transformation tab and expand manipulation tab, or you can simply search join data in the search box. You have join data control and drag it on the canvas. Now we have all the components required to perform join operation. But before performing join on these 2 datasets, we have to understand them. So let's visualize the 2 datasets. We want to find common key columns from both the datasets. This is restaurant customer data, which has 19 columns and 138 rows. Here the key column could be user ID because it tells us about the interests of particular user. Now let's look at the other dataset. This is restaurant ratings dataset, which contains ratings for each restaurant given by a particular user. This dataset also has user ID column. Therefore, user ID can be a key column on which we can join two tables. Now we can talk about join data control. As you can see, there are two input ports and one output port present in join data control. We have to connect these two datasets to these two input ports of join data. The datasets are now connected. Let's go to the properties pane of join data control. We have to select the key columns on which the join operation will be performed. In the join key columns, for L, we have to select a key column from the dataset connected on left input port of the join data control. Click on the launch column selector to select the column. I will select user ID as the key column. Similarly, in join key columns for R, we have to select a key column from the dataset connected on right input port of the join data control. Click on the launch column selector to select the column. I will select user ID as the key column. Next parameter is match case. It indicates whether a case-sensitive comparison is allowed in key columns. It is selected by default and I'll keep the settings as it is. Below this we have join type. There are 4 different types like inner join, left outer join, full outer join, left semi-join. Let's select inner join first. This selects all the rows from both tables as long as there is a match between the columns. The next parameter is keep right key columns in join table. It indicates whether to keep key columns from the second dataset in the join dataset. This option is checked by default. Now we will run the experiment. The experiment has finished running and we can see the output results. Right-click on the output port of join data and select Visualize. We have joined two tables by using inner join. We can see all the user IDs with their profile and ratings they have given to each restaurant. We have two user ID columns which are from two different datasets. So this is the other user ID column which is suffixed by number 2 to indicate that it is from the other dataset. Now let's see the next parameter of join type, which is left outer join. This returns all the rows from the left table with the matching rows in the right table. The result is null in the right side when there is no match. Now we will run the experiment. The experiment has finished running and we can see the output results. Right-click on the output port of join data control and select Visualize. We have joined two tables by using left outer join. If there were no matching entries in the right dataset, then the output would have been marked as null. But there are no null values here because all the entries have been matched. Going ahead, let's see the next parameter of join type, which is full outer join. This returns all the rows from the left table and from the right table. And now we will run the experiment. The experiment has finished running and we can see the output results. Right-click on the output port of join data and select Visualize. Here we have joined the two tables by using full outer join, where there are all the rows from left table and from the right table. Now let's see the last parameter of join type, which is left semi-join. This only returns the records from the left-hand table. If there are multiple matching rows in the right-hand column, an inner join will return one row for each matching column, while a left semi-join only returns the rows from the left table. We will run the experiment. The experiment has finished running and we can see the output results. Right-click on the output port of Join Data Control and select Visualize. We have joined two tables by using left semi-join. As you can see, output result only contains the matching columns from left dataset. Hence, we have successfully learned how to join two datasets by using Join Data Control. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about export data control in Azure ML. This control is used to export the data from Azure ML in various forms. Basically, it writes the dataset to various forms of cloud-based storage in Azure, such as tables, blobs, Hive query, and Azure SQL databases. So let's get started. I have this blood donation data on the canvas. You can also directly download or export this dataset on your local machine. For that, you have to right-click on the output port of this dataset and then select Download. The dataset will be downloaded in its original form. It might be CSV, text file, ARFF, or SVM light file. The other way to get dataset from Azure ML is by using export data control. As mentioned earlier, it writes dataset to cloud-based storage in Azure, such as tables, blobs, Hive query, and Azure SQL databases. So let's get export data control on the canvas. I will search export data in this search box and drag this export data on the canvas. I will connect this dataset to the export data control. So the dataset is now connected and we can export blood donation data into various formats provided by export data control. Let's see different properties of the export data control. The first parameter is please specify data destination. There are 4 different types mentioned under this parameter. Using these types, we can export the data in respective format. So let's see the first type, which is Hive query. Hive query writes the data to a Hive table in an HD inside Hadoop clusters. Hive query is particularly useful for very large datasets, or when you want to pre-process the data using a MapReduce job before loading into a machine learning experiment. Below that, we have Hive table name. In this field, write the name of the Hive table that will store the dataset. After that, we have Edge catalog server URI. In this field, type the fully qualified name of the cluster you created. After this, we have to type Hadoop user account name and password. Next field is location of output data. There are two options in location of output data. The first field is HDFS and the second is Azure. If you select HDFS, then below that you will have to specify the HDFS server URI. Specify the HD inside cluster name in this field, but without the HTTPS prefix. If you want to store your data in Azure, then choose Azure option in location of output data. If you select this option, a bunch of other options will pop up. In these options, you will have to specify Azure Storage Account Name, Azure Storage Key. In the storage key, paste the key that is provided for accessing the storage account. And in Azure Container Name, you will have to specify the default container for the cluster. Next is Use Cached Results. Select this option if you want to avoid rewriting the Hive table each time you run the experiment. Otherwise, you can select this option. This actually depends on what type of data you have, static or dynamic, so select this option appropriately. Once you're done with setting all the properties, hit Run at the bottom of the page. And after that, you can see your data in the Hive table. Going ahead, let's select second option for data destination, which is Azure SQL Database. We have to set following parameters to use this option. So below that, mention database server name, which is generated by Azure. Then write the database name, which is on the server you specified. Here you cannot create a database. It must already exist on the server. Then type server user account name and password that has access permissions for the database. Next is accept any server certificate. Check this option if you want to skip reviewing the site certificate before you connect it and get the data. But let me warn you, this is an insecure option. Below that we have comma separated list of columns to be saved option. Type the names of the columns that you want to write to the database. In data table name, type the name of the table where data will be stored. In comma separated list of data table columns, you will have to specify the order in which columns should appear in the destination table. In the next field, we have to indicate how many rows should be returned to the destination table in each batch. By default, the value is set to 50. Increase this value if you have a large number of rows to write. Below that, there is a checkbox which says allow writer success with sporadic failures. If you want to note warnings in log file and you want to keep the logs, then you can check this option. You can also check use cached results based on your dataset. So let's take an example using blood donation data. I will type my database server name, my database name, and account name, password, I won't select this option. Then we have to type the comma separated list of columns to be saved. So let's visualize the dataset. So we have these columns: recency, frequency, monetary, time, and class. So I will paste the list of columns in the original table, which is over here. In data table name, we will type this, and I will copy this in comma separated list of data table columns. This is where we want the columns to appear in the destination table. And then we will type the rows. We will type 100 rows because our data set is quite large. And I will select use cached results, and let's run the experiment. The experiment has finished running and we can see the green tick mark on export data control, which means that the data has been exported to the destination table. You can actually go to the destination server and see the table. So let's see the next option in export data control, which is Azure Table. The Azure Table Service is a data management service in Azure that can store large amounts of structured, non-relational data. This option will export the data to Azure Table Storage. In the next field, specify the authentication type. You can export data to a public shared resource or to a private storage account. Choose SS if you know that the account supports access via public SS URL. This is a time-bound access URL that you can generate by using an Azure storage utility. Then type or paste the full URI that defines the account and the public blob in the table SS URI field. If your data is in the private account, then choose account option in this field. After that, you must also provide credentials including table account name and the key associated with the storage account, and then type the table name that you want to export. Below that, we have to specify which columns to include in the table schema. For partition key, use the column selector to specify the column that should be used for partitioning the saved dataset for the table in Azure storage. You might ask, why do we need partition key? Tables in Azure are partitioned to support load balancing across storage nodes. All entities are organized by partition. Therefore, the partition property is required for all the table operations. In Azure Table Row Key, use the column selector to specify the column that should be used for the row key property. The row key property is the system property that is required for every entity in the table. It forms a unique index for every row in the table along with the partition key property which you provided earlier. Make sure the columns you specify in row key property and partition key property should be present in the list of destination columns. Otherwise, you will get an error. For Azure Table Origin columns, use the column selector to specify any additional columns from the dataset that you want to save to the Azure table. Also, include the columns selected as the partition key and row key. The next field is Azure Table Destination Columns. In this, specify the names of the columns to write to the table. For Azure Table Write Mode, indicate how you want the export data to behave when data already exists in the Azure table. So we have multiple options over here. The first option is Insert. This will insert a new entity with a unique primary key. The second option is Merge. It updates an existing entity by updating the entity's properties. It does not replace the existing entity. The third option is Replace. It replaces the contents of given entity in a table. The fourth option is Insert or Replace. This is the most popular option. It inserts the entity if entity does not exist. If the entity exists, it replaces the existing one. The fifth option is Insert or Merge. It inserts the entity if the entity does not exist. If the entity already exists, it merges the provided entity properties with the already existing ones. Indicate whether you want to use cached results or not, and once you are done with setting all the properties, hit the Run button at the bottom of the page. The last option in Export Data module is Azure Blob Storage. By using this option, you will get output in CSV, TSV, or ARFF formats. The Azure Blob service is for storing large amounts of data, including binary data. Azure blobs can be accessed from anywhere by using either HTTP or HTTPS. There are two types of blob storage: public blobs and blobs that requires login credentials. Below this, we have authentication type. Choose SAS option if you know that the storage supports access via public SAS URL, and type the full URI that defines the account and the public blob over here. Otherwise, select account option. This will save your data to a private account, and then you can provide Azure account name and Azure account key below that. In the text box given below, type the name of the blob where the data will be stored. In Azure Blob Storage Write mode, Indicate whether you want any existing blob file to be overwritten. By default, Azure Blob Storage write mode is set to error, meaning that you will get an error whenever an existing blob file is found. In File Format for blob file, select the format in which data should be stored. As mentioned earlier, it supports CSV, TSV, and ARFF formats. Select the appropriate format. Select Use Cached Results depending on your dataset. Once you are done with setting all the properties, hit Run at the bottom of the page. And your data will be exported to Azure Blob Storage. So this is how export data control works. Thank you. Hello everyone. In this tutorial, I'm going to talk about train model control. This control is used to train a classification or regression model in supervised manner. Before jumping to the train model, you must have historical data from which train model can learn some patterns. Here I have my training dataset ready to go into train model control. To learn how to get training dataset from original data, watch video tutorial on split data control. You need to provide with training data for which you already know the answers or target. Then Azure ML will train the model by using your dataset and results in a model that attempts to evaluate whether predicate data is correct or not. To use Train Model Control, go to the left pane, expand Machine Learning tab and Train tab, select Train Model Control and drag it on the canvas. As you can see, this control has two inputs and one output port. On the left input, connect classification or regression model. Here I am connecting linear regression model. On the right hand side, connect training dataset, which we have got from split data. Next, we will set some properties of train model. So let's go to the properties pane on the right hand side and click on the launch column selector. Once you're here, select the column name for which you want to predict the outcome. In case of linear regression model, the outcome should have numeric data type or a response variable. If you don't know what outcome you're looking for, then you don't have to worry. Azure ML will try to infer appropriate column for prediction. You can change this selection by specifying a new column anytime. In my case, I will choose price column from automobile price dataset, which has numeric data type. Next, we will run the experiment. This process will take a while if you have a large amount of data. Experiment has finished running and model is trained. Now we can visualize the features and their weights. Here we have the list of features and their respective weights. So this value represents the correlation between this feature and the dependent variable, which is the variable you want to predict. In our case, it is price. So higher the value, higher the correlation among them. You can then connect the output of train model to score model to predict values from new cases. So this is how train model control works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about cross-validate model control in Azure ML. It cross-validates parameter estimates for classification or regression models by partitioning the data. Cross-validation is a standard technique used in machine learning to assess both the variability of a dataset and the reliability of any model trained using that data. Cross-validate model takes an untrained classification or regression model and a dataset as an input. It divides the dataset into some number of subsets, also called as folds, and then builds a model on each and then returns a set of accuracy statistics. By comparing the accuracy statistics for each fold, you can interpret the quality of the dataset and understand whether the model is susceptible to variations in the data. It is simple to use, but it takes a long time to run if you use a large amount of data. I'm using automobile price data for demonstration purpose. We will then train the dataset using multiple regression models using cross-validation to predict the price of a car based on its features. I have already pre-processed the dataset by using select columns in dataset and missing value scrubber. I also have linear regression model which is untrained. Now I will drag cross-validate model on the canvas. You can find cross-validate model under machine learning tab. This model has two inputs and two outputs. The first input should be from untrained model and the second input should be a dataset. The first output will provide scored results containing predictions, and the second output will provide evaluation results by folds where we can measure the accuracy of the predictions and trained model. Cross-validation is useful for reducing bias in a model that can be caused by using a single training set. Instead of dividing the data into just two sets, one for training and one for testing, we use cross-validation to partition the entire dataset into multiple folds and build a model on each fold. By default, cross-validate model uses 10-fold cross-validation. If you want to specify a different number of folds, you can use the partition and sample module, and then select the assign to folds option to specify number of folds to split evenly. Watch video tutorial on partition and sample control to specify different number of folds. Here I will be using default 10-fold cross-validation. For that, first I will connect linear regression model to cross-validate model, and then I will connect the dataset to cross-validate model. Because cross-validate model trains a model, you must specify the response variable. In this experiment, we will select the column price as the response variable. I will keep random seed to 0 to randomize the distribution of instances into the folds, and I will run the experiment. Cross-validate model randomly splits the training data into 10 folds. A fold is a subset of the original dataset. In each iteration over the dataset, cross-validate model uses one fold as a validation dataset and uses remaining folds to train a model. Each of the 10 models is tested against the data in all the other folds. After all iterations are complete, cross-validate model creates a set of performance matrix for all models, as well as scores for the entire dataset. To view the score results, right-click on the left output port of cross-validate model and select Visualize. You can see that two additional columns are created in the output result. First is fold assignments, which indicates which fold each row of data was assigned to during cross-validation. The second column is scored labels, which gives us the predicted value for each row. In the price column, we can see the original price of each car, and in scored labels column, we can see the predicted price of that car. Now let's see how to interpret these results. The first row has been assigned to fold 5. Therefore, this particular model was trained on the data in folds 0 to 4 and folds from 6 to 9. This model also predicts the value of scored labels for this row as 16,157.13. Now let's go ahead and see the second output result of cross-validate model. It contains a summary report, and a careful review and comparison of fold results can help you to identify irregularities in the dataset or the model. The first column, fold number, is an identifier for the current fold results. The second column, number of examples in fold, gives us the total count of rows assigned to each fold. Model indicates the type of learner that was used in creating the models. The metrics that are provided depend on the type of the model that we are evaluating. Since we have used linear regression model, the metrics are mean absolute error, root mean squared error, relative absolute error, relative squared error, coefficient of determination. Now, mean absolute error measures the average magnitude of the errors in a set of forecasts without considering their direction. It is the average over verification sample of the absolute values of differences between forecast and the corresponding observation. Root mean squared error is a quadratic scoring rule which measures the average magnitude of the error. It gives relatively higher weights to large errors. It is useful when large errors are undesirable. For both mean absolute error and root mean squared error, lower values are better. Relative absolute error is relative to a simple predictor, which is just the average of actual values. It shows how large the error is in relation to the correct value. Relative squared error is relative to what it would have been if a simple predictor had been used. The relative squared error takes the total squared error and normalizes it by dividing the total squared error of the simple predictor. Relative absolute error and relative squared error are very similar. The coefficient of determination tells us how well your predictions are correlated with the true outputs. The closer to 1, the better. Here we have got a pretty good coefficient of determination, which means that our predictions are reasonable. So based on the cross-validation results, you can tune the model parameters or decide which model to use in the scoring experiment. Because cross-validate model trains and validates the model multiple times, it is much more computationally intensive and takes longer time than validating on random split to complete. So this is how cross-validate model works. Thank you. Welcome to the series of Azure ML Toolbox video tutorials. Today you will learn how to use score model and set up a web service in Azure ML. So let's talk about score model first. Score model scores the predictions for a trained classification or regression model. The predicted value can be in many different formats depending on the model and your input data. If you're using classification model to generate the scores, then score model gives a predicted value for the class as well as the probability of the predicted value. If you're using regression model to generate the scores, the score model will generate the predicted numeric value. If you're using image classification models, the score might be the class of object in an image or a Boolean value indicating whether a particular feature was found or not. I have this entire module ready to go into score model control. To watch how I configured the existing module on the canvas, watch video tutorials on select columns in dataset, split data, and train model control. Let's drag score model on the canvas. Connect output of train model to the left input port of score model and connect right output port of split data control, which is test data, to the right input port of score model. In the properties pane of score model, there's only one option to configure, which is append score column to output. This is checked by default and will attach the predicted score in the output result. Now let's run the experiment. Let's visualize the output results. As you can see, this is the scored dataset, and since we are using linear regression model, the output only has scored label column and not scored probabilities column, which you get when using classification model. Here the price column indicates the original price of the car And the score label column indicates the predicted price of each car by using different variables such as body style, wheelbase, horsepower, etc. So in the first row, make of car is Nissan, and there are a bunch of parameters in front of it. And the second last column is price, where the price of Nissan is 13,499. And in the last column, a scored label is generated for Nissan, which is 16,865.85. This is the predicted value of Nissan based on all the parameters in this row. If you want to evaluate the accuracy of predicted values, connect scored dataset to evaluate model to generate a set of metrics used for evaluating the model's accuracy or performance. There are some exceptions or special types of models where you cannot use score model, but you can use custom scoring modules in such cases. For scoring a clustering model, we can use assign to clusters control, which would score the clustered results. If you are creating recommendations or generating data for evaluating a recommender, then you will have to use Score Matchbox Recommender model. Once the prediction results have been understood, the experiment can be published as a web service so that we can deploy it in various applications and be called to obtain price predictions or any new automobile model. So the input for the web service would be from right input port of score model. And for the output, we can select desired output columns by attaching select column in dataset control to the output port of score model. I am only interested in scored labels column, which is predicted column. So I will just select scored labels and I will drag it to selected columns and then press OK. Once you are done with selecting output columns, we can go ahead and set up web service. To set up web service, we have to go to Web Service tab and then drag input and output controls on the canvas, which will attach it to the desired locations. Or we can also hit the Setup Web Service button, which is at the bottom of the page, which would determine where to attach these two controls. Now I will use Web Service Input and Web Service Output controls. I will connect output of Web Service Input to the input port of Score model. And I will connect the output of Select column in dataset to the input port of Web Service Output. Now we are ready to deploy our experiment. But before that, we first have to run the entire experiment to ensure that all the updates in experiment have been verified at least once. So I'll run the experiment. Now we can deploy the web service. To do so, click on Setup Web Service option at the bottom of the page. Here we have got two more options. The first option is Predictive Web Service, which is recommended by Azure ML by understanding our data set, and the other one is Deploy Web Service. We want to click on Deploy Web Service. You will be headed to the Web Services page where you can test the web service. So click on the Test button and a new window will appear where you will have to enter the data to predict. I will type the first entry from our dataset, which was for Nissan make. And then press OK. The web service has returned the results for our input. Let's expand this tab. We can see that the score model has returned the test results as 16,865.85. To verify this result, let's click on View Latest under Published Experiment. Let's see the output of score model to verify the scored label value for the first entry. As you can see, the first entry is for Nissan make and other parameters are exactly same that we have used to test the results. And in the scored labels column, it indicates 16,865.85, which is exactly same as the value returned by the test results. Hence, we have verified the results for scoring model. So this is how we can use score model and web service input-output controls. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today you will learn how to use Evaluate Model Control to evaluate the results of a classification or regression model with standard metric. We can use Evaluate Model to measure the accuracy of a trained classification regression as well as clustering model. Note that the evaluation matrix for each type of model will be different. So you just need to provide a data set containing scores generated from a trained model, and the evaluate model computes a set of industry standard evaluation matrix. This existing module was used and configured in score model video tutorial. So go ahead and watch that video tutorial to see how I configured each and every control in it. Now I will drag evaluate model control on the canvas. Typically, we connect score dataset output of score model to the input port of evaluate model. However, it is not necessary to connect output from score model always. You can also connect any dataset which contains a score column. And on the second input port, you can optionally connect one more score dataset. This feature is useful because you can easily compare results from two different models on the same data. Or you might compare scores from two different runs over the same data with different parameters. We will first evaluate just one score dataset, and after that we will connect one more score dataset for comparison. And now run the experiment. Let's click on the output port of Evaluate Model and select Visualize to see the evaluation results. As I mentioned earlier, evaluation matrix for each model will be different. Here we are using linear regression model. So the matrix are mean absolute error, root mean squared error, relative absolute error, relative squared error, and coefficient of determination. In general, the term error represents the difference between the predicted value and the original value. The absolute value or the square of these differences are usually computed to capture the total magnitude of errors across all instances, as the difference between the predicted and true value could be negative in some cases. This matrix helps us in measuring the performance of a regression model in terms of mean deviation of its predictions from the true values. Lower error values means the model is more accurate in making predictions. An overall error matrix of 0 means that the model fits the data perfectly. But in reality, there is no model whose predictions are 100% accurate. So if you get 100% accuracy, then something might be wrong in your model. The coefficient of determination is also a standard way of measuring how well the model fits the data. A higher proportion is better in this case, where 1 indicates a perfect fit. I have explained each of these terms in cross-validate model tutorial in detail. So in our case, relative absolute error and relative squared error are pretty low, and coefficient of determination is close to 1, that is 0.82. Therefore, we have a very good accuracy for predictions. As you can see, Evaluate Model can take two scored datasets as input and compare the results of both so that we can find out which model or which parameters suits the best for our data. So let's drag another regression model. I will select Bayesian linear regression model now. Let's just keep default parameters over here. Now I will train this model. So let's connect Bayesian linear regression and training dataset to train model. On this input, we have to connect untrained model, which is Bayesian linear regression, and here we have to connect a dataset. Here we will connect our training dataset from split data. Now we have to select a column on which we will train the model. I will select Rice column and press OK. Next, we have to score the trained model. So let me drag score model on the canvas. So let's connect train model and test dataset to score model. This is our test data. And finally, I will connect output of score model to evaluate model to compare linear regression and Bayesian linear regression. By doing this, we can find the best parameters as well as the best learning algorithm for our dataset. Now I will run the experiment. Now let's visualize the output results. We have got two entries over here. The first entry is for linear regression and second entry is for Bayesian linear regression algorithm. The coefficient of determination for Bayesian linear regression is higher than the coefficient of determination for linear regression algorithm. So this coefficient of determination tells us that Bayesian linear regression is more suitable for our data and gives us more accurate results. Also, all the error terms in second row are lesser than the first row. Therefore, Bayesian linear regression minimizes the errors and maximizes coefficient of determination. So this is how we can compare and analyze the evaluation matrix for different learning algorithms. If you remember, we did the same thing in cross-validate model tutorial, that is measuring the performance of the model. Evaluation and cross-validation are standard ways to measure the performance of your model. They both generate evaluation matrix that you can inspect or compare against those of other models. So if both of them gives us evaluation matrix, then which one to use? Evaluate model expects a scored dataset as input. However, cross-validate model expects an untrained model and a dataset as input. Cross-validate model will divide the dataset into 10 different folds and provides the evaluation results for each fold. Therefore, you will generate some number of models per trial. This will help you in finding perfect parameters for your learning algorithm. Cross-validate model will prevent you from overfitting the model. After that, train your model on all the training data with new parameters and then apply scoring and evaluation model on it. Keep in mind, machine learning is not about finding the best model. It is about finding the best parameters for the learning algorithm. Therefore, we have learned how to utilize evaluate model to measure the accuracy of a model or learning algorithm. Thanks for watching. Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about performance measures in Azure ML, that is accuracy, precision, recall, and F1 score. So let's get started. When you build an experiment in Azure ML, you need to score and evaluate it to check the performance and accuracy of the results. To do so, in my experiment, I have created a trained model, and this trained model is passed on to score model, and score model is connected to evaluate model. So for this video tutorial, I'm using the same experiment that I had created in two-class boosted decision tree video tutorial. So you can watch how I created this model in that video tutorial and then come back here. So in this experiment, we are using Titanic dataset. The score model will give the predictions about the survival of the passengers on Titanic, and then evaluate model will check the accuracy of those results. Let's visualize the output of score model to see the predictions, which are also called as scored labels. So survived column tells us the actual values of survival, that is whether a person survived or not. And in scored labels column, it tells us the predicted values for those passengers. 0 means passenger died and 1 means that passenger survived. And next to this, we have scored probabilities column, which is used for predicting the scored labels. If the scored probability is less than 0.5, then scored label is 0. And if it is greater than 0.5, then scored label is 1. As we have seen our scored labels, now we will go ahead and evaluate the performance of these scored labels. For that, right-click on the output port of Evaluate Model and select Visualize. The first thing you will see here is the ROC curve, and we can determine whether our ROC curve is good or not by looking at AUC value. So when you scroll down, you will see all these values, which are AUC, accuracy, true positives, etc. These values are called as confusion matrix. A confusion matrix is a table that is often used to describe the performance of a classification model on a set of test data for which the true values are known. All the measures except AUC can be calculated by using leftmost 4 parameters. So I have created this PowerPoint which will allow you to understand these numbers better. So this is the comparison of actual class versus predicted class. So true positive and true negatives are the observations that are correctly predicted and therefore shown in green color. We want to minimize false positives and false negatives, so they are shown in red color. These terms are a bit confusing. So let's take each term one by one and understand it fully. So true positives. These are correctly predicted positive values, which means that the value of actual class is yes and value of predicted class is also yes, then we get true positive value. In our case, if the value of survived is yes and experiment predicted that this passenger will survive, that means we have got true positives. Next is true negatives. These are correctly predicted negative values, which means that the value of actual class is no and the value of predicted class is also no. In our case, if the passenger is not survived and experiment also tells you that this person won't survive, that means we have got true negatives. After that, we have false positives and false negatives. These values occur when your actual class contradicts with the predicted class. Let's say for false positives, actual class says this passenger did not survive, but predicted class tells you that this passenger will survive. Similarly, for false negative, actual class value indicates that this passenger survived and predicted class tells you that this passenger will die. Therefore, these are incorrect predictions and we want to minimize these. Once we know what is true positive, true negative, false positive and false negative, we can calculate accuracy, recall, precision and F1 score. Let's start with accuracy. Accuracy is the most important performance measure and it is simply a ratio of correctly predicted observations to the total observations. One may think that if we have high accuracy, then our model is the best. Yes, accuracy is a great measure, but only when you have symmetric datasets where values of false positives and false negatives are almost same. Therefore, you have to look at other parameters to evaluate the performance of your model. For our model, we have got 0.803, which means our model is 80% accurate. Now let's talk about precision. Precision is the ratio of correctly predicted positive observations to the total predicted positive observations. The question that this metric answers is of all passengers that labeled as survived, how many actually survived? High precision relates to the low false positive rate. We have got 0.788 precision, which is a pretty good value. Next is recall. Recall is the ratio of correctly predicted positive observations to the all observations in actual class, yes. The question that this metric answers is of all the passengers that truly survived, how many did we label? We have got recall of 0.631. Next is F1 score. The F1 score is the weighted average of precision and recall. Therefore, this score takes both false positives and false negatives into account. Intuitively, it is not as easy to understand as accuracy, but F1 score is usually more useful than accuracy, especially if you have uneven class distribution. It works best if false positives and false negatives have similar cost. If the cost of false positives and false negatives are very different, it is better to look at both precision and recall. In our case, F1 score is 0.701. After that, we have AUC, which is area under the curve. We want to maximize this value. Larger the area under the curve, better the predictions. But if you get perfect 1 in this field, then either there might be something wrong with your model or you don't have enough sample of data. We have got 0.835 in this field, which means our model is good. This measure is used to determine best performing model. Next is threshold. The threshold lets you change the balance of two types of prediction errors, false positives and false negatives. The cost associated with one type of error can be much higher than the cost associated with the other. If that is the case, it makes sense to have error on the side of safety, which means you will accept a much higher number of cheap errors to reduce the number of expensive errors. Therefore, in order to determine optimal value of threshold, you first need to determine the cost of false positives and false negatives. You can move this slider wherever you want. I have kept it in the middle since I don't have same false negatives and false positives. So this is how you can interpret whether your model is good or not by looking at confusion matrix. Thanks for watching.